All right, this is going on page 63 when we are done. Compound interest, which again is not new to you, just like the other stuff wasn't new to you. But the idea, obviously, is that as you go through this, you have a little bit more of an understanding of what's happening, and we're not just plugging numbers into a formula, right? So we've got interest. We talked about interest yesterday, like the exponential stuff. And so you could have maybe let's say a yearly interest rate, right? So at the end of every year, you get so much interest on whatever money it is that you have. Okay, and that, your 5% or whatever it is. But then if it's compounded interest, and let's say it compounds monthly, then you're going to get a little bit of interest the first month, and then the next month, the stuff when they calculate the interest, it's calculated on the total now, so you get interest on the interest, basically. And the more it compounds, the more interest on the interest that you get. All right, and that's what compounding interest means. And here's what the formula looks like. A is equal to P times 1 plus R divided by N to the N times T power. So it's not just 1 plus R, it's 1 plus R over N. Because basically you have to take the rate and divide it by however many times it's being compounded, because you're not going to get 5% at the end of the first month and 5% at the end of the second month and so forth. You get a little bit at a time, which is going to accrue better than just having 5% at the end. Your A stands for your total amount or your total balance, the total amount that you have. P is the principal or the initial amount. R is the rate. N is the number of times compounded. And that's always based on a year, so that's yearly. Number of times compounded yearly. And the T is the time in years. Okay. All right. We're all good with that. Right, so it looks a little bit different, but it has to do with, how often we're compounding here. So number 1 says, Dave invests $300 in an account with a 5% interest rate. If he makes no other deposits or withdrawals, find his account balance after 15 years if the interest is compounded with the following frequencies. So there's 2 things we got to find before we start substituting stuff in. T, so what would T be for this one? No, what would T be? 15. T would be 15. What would N be? 2, because semi-annually means it happens twice a year. A semi-annual sale happens twice a year, so N equals 2. Then we substitute it in. We get A equals, so our initial amount is $300 times 1 plus the rate, which is 0.05, divided by 2 to the 2 times 15 power. Okay? And then you can just type it in the calculator just like that. There's no need to simplify at all. Great. Type it in the calculator and it'll be even better. Get 629.27. Don't just write down my numbers. Make sure you're pushing the buttons too so that we know that you're getting it out right. Okay. Marco, I think that's your stuff right there that was under a chair yesterday. Oh, that's what you were looking for. All right, so let's look at B. So this is semi-annually, and then we've got monthly. So what would T be here? 15. What is N going to be? 12. Okay. So do you think you're going to get more money or less money than semi-annual? More. Okay, that makes sense. So let's see how much more. So A equals 300 times 1 plus 0.05 divided by 12 to the 12 times 15 power. Absolutely, yes. And you don't have to do multiplies. You can just make it look exactly like that in your calculator and you'll be good. You get 634.11. So it is more. It's only about $5 more, but hey, if you got an extra $5, I'll take it, right? We didn't put that much money in to begin with anyway. But understanding how if we compounded it daily, then we'd have even more than that. Okay, we good? All right, so that's a very good question. We'll get to that. Hold on to that thought, and I'll answer that in a minute. So number 2, we're not going to do the whole problem because I think that you can substitute numbers in. Let's just make sure we can get the right numbers out of this. If $2,500 is deposited into a savings account earning 8% annual interest, how much will be in the account at the end of 25 years if the interest compounded, blah, blah, blah. All right, so what is T here? 25. What would N be? 4, because quarterly means, like, there's 4 quarters in a dollar, right? It's 4 every 3 months. All right, so daily, my time would still be 25. What would N be? 365. And then we're not going to work those because I think that you can get through that just fine. We are going to look at number 3, though, because there's some vocabulary here that's important as well. Any questions on this so far? All right. When Amelia turned 6, her grandparents opened a college savings account for her with an initial deposit of $500. The account earns 3.2% interest compounded bi-monthly. If her grandparents make no other deposits or withdrawals, how much money will be in the account when Amelia can access it at age 18? Okay, so one thing that always comes up when we do this is that no other deposits or withdrawals. I mean, most of the time when you put money in an account, you're either going to take some out or put more in, like if you're saving. But we're just looking at this as let's pretend like this is all that's happened. But the word bi-monthly here, okay? Got to make sure that you understand what that means in context because it can mean different things in a different context. So our semi-annually means that it happens twice a year, right? Semi-monthly would mean twice a month. Okay? A bicentennial is every 200 years. Bi-weekly is every 2 weeks. However, bi-monthly is not every 2 months. Okay, not in the financial world. By definition, it should be every 2 months because that's what biweekly is and that's how it means differently. But when you look up like financial stuff or mortgage stuff and you're talking about bi-monthly, like you can pay your mortgage every month or you can pay it bi-monthly or bi-weekly. So bi-monthly means twice a month. Bi-weekly means every 2 weeks. They don't even agree with themselves, okay? So what truly bi-monthly means literally is every 2 months. However, when dealing with financial stuff, bi-monthly means twice a month, okay? So just want to make sure that we all understand that. That may have been what your concept of it was anyway, but if you go Google it, you get differing things. But if you look up like bi-monthly and bi-weekly together, that's how they do it. So this does mean twice a month here. So our T, what would T be in this problem? 12, right? And then what is N? 24, because it happens twice a month. So then we can just substitute this in. A is equal to, they start with $500. Then we get 1 plus, the rate is 0.032 over 24 to the 24 times 12 power. And type all that in. $733.88. Okay, and if you don't agree with me and you can't figure out why your calculator isn't saying the same thing, let me know. If you're having issues finding buttons on the calculator, let me know. Like, we'll get it figured out, okay? All right, flip it over. I want you to do number 4 on your own, 100% on your own. Number 4, yes. Oh, I think they're buried on my desk. They are. They're buried right there. Slide them out. There you go. Say that one more time. I didn't hear that. Can you do this in the real world was all I really heard. You said, can I do what now?
Can I deposit my own money and then get that money back?
Oh, yeah. Oh, yeah, absolutely. Well, there's all kinds of savings accounts. So it's just your regular old bank, okay? Like most people have a checking account and a savings account, right? And just your general savings account at the bank is not going to have a great interest rate just because in that savings account, really you're putting money in and taking money out a lot, so they don't offer you a very high interest rate. Off the top of my head, I honestly don't even know what they are, but it's just not great. Yeah, if you want a better interest rate to put money in and just not touch it, I mean, yeah, there's ways to invest or whatever, but then there's some banks and financial institutions, credit unions, offer other kinds of loans, meaning maybe not loans, I'm sorry, other kinds of savings accounts, like maybe sometimes they're called like Christmas accounts, which means you put the money in and you're pretty much not allowed to touch it until like Christmas time, like a year, and since you're not allowed to touch it, you will get a higher interest rate. Like we have some money put aside that we're trying to use for college for our kids, and ours we don't have there's not a fee for us to take any money out, but they have an option where we would get a much better interest rate if we put it in there and said we're not going to touch it for at least 5 years, because what the banks are doing is they're using your money and investing it in other ways, so that's why they give you an interest rate. They're making way more money than what they're giving you, so you can get a better interest rate if you shop around for your loans. But absolutely, you put it in there and you just don't touch it. And then even if you just don't touch it, if you just keep putting a little bit at a time and it accrues, then yeah, you can absolutely make money. Real good money. Okay. So t equals 10, what is in here? 2, semi-alien, n equals 2. All right, so I got sidetracked here, so let's see. 750 times 1 plus 0.004 over 2, right? To the 2 times 10 power. 2 times 10 power. Bleh. Who wants to give me an answer? Okay, so what's the answer? $780.58. Do we all agree with that? Yes, we all agree with that? What if I told you every single one of you is wrong? You're wrong too, sorry. You're one. Tell me why we're all wrong. Because it's what? Ask how much interest. And Ashley caught it. She's not even really technically in this class, and she got it. Okay. Yes, so thank you, Donna. How much interest will she have earned? Now, do you need this number? Absolutely, we need this number. But then, a little thing disappeared again. Look. I don't know. So the actual amount of interest earned is $30.58. Okay. So now notice on the other ones, like I'm not making you write the sentences on these like I did on the others, but if it's not just the total, then you need to say like what it is at least. Okay. We good? Now it doesn't matter how good your skills are and how brilliant you are. If you don't answer the question that's being asked, you're still wrong. Okay. So make sure that you're actually answering those questions. All right, so now I want you to do number 5. Okay, so how do you switch it to a decimal? You do the SD key. right above delete. We figured out it stands for standard and decimal. I don't know why, but whatever. But that changes it back and forth. Yeah, that thing. Okay, and I'll go ahead and I'll even give you the answer, so we'll see if we're getting it, and then we're going to talk about some other things on these calculators. Okay, so are we getting this number? Yes. Okay. So if we got that number, then I know you can get it. But let me show you some other things, like if you don't already love this calculator, something that's going to make you love it. So you know where the fraction button is, right? So I want you to hit the shift key and then the fraction button. And that gives you a mixed number to fill in. So go ahead and here and type in 2 3/8. So you put a 2 in that box, arrow to the right, that's a 3, arrow down, 8. So it literally says 2 3/8 in your calculator. We all got that? Then you hit equals. Well, it made it into an improper fraction for you. Great. But then if you want the decimal, okay, so this 2 3/8% is the same as 19/8%, right? And if I want the decimal, I hit the SD key, and I get 2.375%, right? So that's how you can get through all that stuff. So do I put 2.375 right here? No, because it's a percent. So if I'm going to put a decimal over there, I put in point what? 0.02375. Okay. But what if that isn't a nice, decent decimal? What if it's a repeating decimal and I don't get to round, right? If it was like 0.3 repeating, I don't get to round. So I could leave it as a fraction. Of course, I'm still not putting 19/8 over there either. When I move the decimal place over twice to change it from a percent to a decimal, that's the same as dividing by what? What do you divide by, though, to move it? 100. It's the same as dividing by 100. And dividing by 100 is the same as multiplying by what? 1 over 100, right? So if I took this, and I want to change it into a decimal, basically, but not really, and I want to divide by 100, it's the same as multiplying by 1 over 100, so I could have put in 19 over 800 in for my rate. Okay, and that keeps it exact for me. Now, I'm not saying you have to do it or it's the better way to do it on here, but I want you to type it in that way because I want you to see what else this calculator can do. When you start typing this in and you hit the fraction button here, hit it again, and it'll give you a fraction and a fraction. Then you can put 19 over 800 in the numerator and 4 in the denominator. Huh? That's for me? Aww. It is my birthday. How sweet. Aww.
Happy birthday to you.
Stop it.
Happy birthday, dearest Dennis. Happy birthday to you.
Aw. Thank you. No, these are for my husband. He never sends me flowers. Usually because I threaten him because I'm like, flowers are such a waste of money, but that's so sweet. Aw, that's so sweet. I'll leave it in my video. I know, he like slammed the door open and take. And he was like, these are for you. Thank you. Oh, I know I'm still recording. So this is entertainment for anybody that has to watch the video. We'll see if anybody actually watches the video, because then they'll comment on it, right? We'll see, like, I heard your video. It sounded a little crazy. It is my birthday. That's so sweet. They're so pretty. All right. Oh, I know. What a nice guy. All right. Now that we're talking about finances, this is not a good use of your money. I'm just kidding. All right, so everybody okay with this? You see what? Did you actually type it in? I don't know. When the door swung open, I don't remember what I was saying, but fraction and a fraction. Okay, and so you get the same answer. And again, maybe not the way that you would have thought to do it, but I do want you to see that you can do that on these calculators. All right, so continuous compound interest. Continuous makes you think you got to do what? E. Good. E. All right, so in some cases, interest is compounded continuously. So let's watch a little video here about E.
Give me another video.
No, it's not a song. It's actually informative here. Very good question. So her question is, what's the difference between compound interest and continuous? And you had a question earlier that said, like, is there a limit to how much you can compound, right? Like if we are doing daily, month, or monthly, then daily, then hourly, or whatever. So this kind of addresses both of those things, and we'll talk about this more.
We made a video about pi, the ratio of a circle's circumference to its diameter. We've made a video about pi, the ratio of a circle's circumference to its diameter. But there's a less famous, but equally fundamental number known to anyone who's taken high school algebra. It's about 2.71828182845945, and so on. And it was first defined by Jacob Bernoulli, but later Leonhard Euler called it E, and the name stuck. Bernoulli first defined E through compound interest. Now, compound interest says that you get a little bit of money in interest every period.
Okay, so did
and
that kind of
money
answer
you
those
gain
questions a
helps
little
you
bit?
gain even more interest
Yes,
next period.
maybe. So
in
the
other
question
words, your
about
interest compounds.
is there a limit
So
to like
if
how
you stick
much
$1 into a
how
bank
much it can
account with
compound?
100%
Well, yeah, I
interest
mean,
rate
you're not going to
compounded
have
annually,
you're
you'll get
probably not going to
$2
find
at the end of a
a
year.
savings account
If
that's
it's
going to
compounded
compound daily. I
semi-annually,
mean, maybe
you'll
monthly,
end up
maybe
with
quarterly,
$2.25.
and maybe even continuously.
Quarterly, and you'll end up with
But if it does,
$2.44.
every day,
Monthly,
every minute, every hour, every
$2.61.
second, every millisecond,
Weekly,
and then we're getting closer and
$2.69.
closer and closer to E,
See where we're
and
going?
that's where that
If you
number
increase
is
the
headed
number
for
of
you.
compounding periods a year
What was your
towards
question? I forget.
infinity,
What was the difference?
then you'll get
Okay.
closer and
So the
closer
difference
to
isn't
E
how many
dollars.
times it's
In
compounding. So
statistics,
basically
it
that
describes
n
the
is
most
approaching
important
infinity.
statistical distribution,
I think
the
that you
normal.
will understand that
In
maybe a little
biology,
bit better
it
when you
models
truly
populations of
understand
species
limits,
through
and
the
that comes
logistic function.
in calculus.
In physics,
and
E
you
describes
use
the
E,
exponential
you have to
decay of a
understand E in
radioactive
natural
material.
log.
So,
You don't
while
get that.
E may not be as famous as pi,
Are y'all
it's
dealing with E
easily as
very much
fundamental
yet?
and
Because
immensely
if not, you
important.
will. Derivatives. Okay. And then so to understand, but you understand limits a little bit better, right? Okay. And so once you understand that, if you try and pull all that stuff together, then, maybe I can explain E to y'all a little bit better than I can them because they don't have the limit concept down yet. But continuously, here's the thing though. Yes, it's better if we could understand a little bit deeper, and we will get there. But understanding just that there is a difference and how to handle both of them can honestly help you as just a human being out in the real world trying not to get ripped off by banks. So your formula looks like this. A is equal to P times E to the RT power. It's the exact same formula we used yesterday. Okay? So yesterday we talked about it being continuously increasing or decreasing, and this is continuously compounding. It's the same concept, except we're not really talking about decreasing because we're talking about interest. All right, so we're just going to do 6 or 7. It doesn't matter which one. Which one you want to do?
The easier one.
7? Okay, I heard 7. I don't know which one's easier, but all right. So it says to find the balance of an account after 5 years, if $1,200 is initially invested at an interest rate of 12.5% per year, compounded continuously, so there you go, that's E, and there are no other deposits or withdrawals. So we know we're using this formula. A equals, we do 1,200 times E to the rate is 0.125 times the number of years, which is 5. Okay. So it's just the PERT formula. Your PERT formula is your continuous, okay? Because N is approaching infinity, and that's where E is coming from. And then you just type it in the calculator. And you should get this number. What questions do you have at this point? Okay. So we are going to do number 8. So let's read it, and then before we do any math, I want you to make a prediction here. It says, Carla is investing $1,500 in a new 30-year retirement account. Determine which of the interest rates and compounding periods shown to the left would be her best investment option. Okay, so option A is 5.5% annual interest compounded monthly. B is 2.7% annual interest compounded continuously. All right, so and after 30 years, which one do you think would be better? So I want you to decide on your own. I'm not going to ask you what it is, and you don't have to tell anybody. You just think about it without, I don't want you to calculate anything. Just pick A or B. Not yet. I just want you to just pick it. Just well, continuously is it never stops. It's infinite. So you pick one, circle it, you don't have to tell anybody. And then I also want you to think, is it going to be a whole lot different or just a little bit different? Okay, just kind of make those predictions before we do anything. And then you are going to calculate it. So A and B. Okay. Just pick one but then actually find the real answer. Because that's not how we really answer questions. We don't just randomly pick things. I know. Wish somebody had told you sooner, right? Yes, Tuesday. Dang it. Okay. Okay. Well, yes, but at the same time, even if you picked A, did you think it was going to be that much better? So even if you thought option A was better, that's considerably better, right? Do you think it's important for you to have some concept of this stuff, period? I mean, that's not why we do it in pre-cal, so that you can have some concept to be a useful citizen when you leave the real, when you're out in the real world. But that's what I want you to get out of it, really, is that y'all aren't too far away from having to decide on retirement accounts. Because when you get out of college and you have your first big boy or big girl job, you have to make those decisions when you sign all your paperwork, right? Because you're going to be putting money into retirement from day one. And so some fast-talking investment person's probably going to be trying to talk you into one thing or the other, but you want to be able to sit down and be able to actually think through it yourself and at least know that there is a difference between continuous and monthly. Now, I want to point this out to you, though. I need to change this question where this isn't that much lower. It is possible to have a lower interest rate, but it compound continuously, and it still be a way better option than this one, right? and or at least for them to be closer. But yeah, it's option A. So make sure you actually answer the question as well. Okay, we good? What questions do you have? Well, if they were the same interest rate, the continuously would be better. But the interest rate's different, so that's one of the things that affects it. But again, I still could have different interest, like this still could be a lower interest rate and then be better, or or whatever. Okay.
I knew about it because it asked if it's 20 instead of 2.